Good day! I'm Teacher Bernie and I'm here to discuss a new topic that you'll find interesting. Because as we know, science is fun! On our last video, we discussed the 3 laws of motion. Now, let us state them one by one for us to recall the concepts. Law of inertia states that a body at rest remains at rest, or if in motion, remains in motion at a constant velocity unless acted by a net external force. And what about the second law? The law of acceleration. The law of acceleration states that the acceleration of an object as produced by the net force is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of the object. And how about the third law? The law of interaction. What does it states? It states that for every action, there's an equal and opposite reaction. And now, let us have our coffee with milk. Let us proceed to our new lesson. What is our enabling competency? Our enabling competency demonstrates how a body responds to a change in motion. And now, what is our milk? Our most essential learning competency is infer that when a body exerts a force on another, an equal amount of force is exerted back on it. What are our lesson's objectives for today? 1. Identify the forces acting on an object at rest. And number 2, examine the conditions when two forces are balanced. 3. Explain the effect of unbalanced force on the state of motion of an object. And 4. Determine the net force that acts in an object. First, let us discuss the balance force. We have learned that all objects fall because gravity pulls on them towards the center of the earth. Examine the pictures showing the pen and the flower vase. What makes the pen and the vase stay at rest? The pen stays in place because there is a force that acts on it. This is supplied by the string, which is referred in physics as tension force. Tension force is the force which is transmitted through string, rope, and wire when it is pulled tight by the force acting at its end. The vase, on the other hand, stays at rest because of the upward push exerted on it by the table, which is referred to us as normal force. Notice that both tension force and normal force counteract the pull of gravity that acts on the objects, which makes them stay at rest. In both cases, we can now infer that the objects remain at rest because the forces acting on the pen and on the vase are 1. They are equal in magnitude, 2. Equal force but opposite direction, and 3. They are in the same line of action. The forces are said to be balanced. What is balanced force? Balanced force are forces that are equal in magnitude and in opposite direction, so there will be no motion in an object. Here are some examples where you can see balanced forces. Mango fruit hanging in the branch. Tension force exerted by the stalk is equal to the force exerted by the gravity. Thus, no motion is produced. Another example is the plate on the table. The upward force exerted by the table, known as normal force, is balanced with the force of gravity. Therefore, the plate is at rest. And how about unbalanced force? If you cut the string connected to the pen will fall. The pen falls down because there is no more force acting on it to counteract the pull of gravity. In other words, the forces acting on the object are no longer balanced. If an object initially at rest is under unbalanced force, it moves in the direction of the unbalanced force. And now, what is combining force? When we combine or add forces to determine the net or unbalanced force, let us recall the algebraic signs of positive and negative. to indicate the direction of the forces, unlike signs are used for forces acting in opposite directions, like in the case of the book lying on the table. The force of gravity and normal force are assigned opposite sides. The normal force is given a positive sign, and the gravitational force is given a negative sign. If both gravitational force and normal force are given a magnitude value of 3 units, then the net force along this line will be net force is equal to normal force plus gravitational force. 3 units plus negative 3 units is equal to 0. If the sum of the forces equate to 0, they are considered balanced. If the algebraic sum is not equal to 0, the forces are not balanced. The non-zero sum is the net or the unbalanced force. This unbalanced or net force would cause a change in body state of motion. Let's go back to activity number 1. The base on top of the table. The base on top of the table stays at rest because it has a normal force of 5 units and a gravitational force of 5 units as well. Using the Gresa method, let us find out what will be the net force of the base. Given normal force is equal to 5 units, gravitational force is equal to 5 units as well. Required net force. Equation: net force is equal to normal force plus gravitational force. Solution: net force is equal to positive 5 units plus negative 5 units. Then the answer is 0. Therefore, there is no motion produced or the object is at rest. And now it's time to say goodbye. Always remember, science is fun!